So again, the practice test says polarity. The practice test says Lewis dot structure, molecular geometry, and polarity. Your test will actually be electron geometry in the middle column and molecular geometry. So, and that's not adding. If you're doing molecular geometry, you already had to do electron geometry to figure that out, right? Because remember, electron geometry is just if you could see all the lone pairs, what shape would it be in? And then molecular geometry is, okay, now if the lone pairs are still there, but if you can't see them, what does it look like? Right, so as a reminder, there's a copy of the practice test. Is this the practice test?
You print more?
No, it's okay. I was just, what's the compound on the practice test that has you do the NH2F? And then did I see a Tegan? As far as the geometries, you can either draw them as long as you draw them properly in 3 dimensions with the wedges and the dashes, or you can tell me the name of the geometry. I would recommend at least having, there's only 5 electron geometries and everything fits into one of those 5 categories. I would recommend at least having those names memorized. I don't know, unless you're good at memorizing, I don't know that I would memorize the molecular geometries. I would learn how to draw them. But either one is an option. Yeah. So electron jump. So let's go through this example and we'll see it. So what's the Lewis dot structure going to look like for this one? How many electrons do we have to work with? Or Gloria, did you have another 14? Good. Yeah, we have 7 from fluorine, 5 from the nitrogen, 1 from each hydrogen, right? So 7 electrons plus 5 electrons plus 2 times 1 electron gives us a total of 14 electrons. So our Lewis dot structure, what has to go in the middle out of nitrogen, hydrogen, and fluorine? Nitrogen. It's got the most vacancies. Fluorine will never be in the middle because it's the most electronegative element that there is. And hydrogen will never be in the middle because it can only make 1 bond. So hydrogen can't go in the middle by definition, and same with fluorine. So in this case, nitrogen goes in the middle. Got a fluorine, a hydrogen, and a hydrogen. Then how do we start divvying up the electrons? Start by doing all the bonds. We know they all have to be connected, right? So that used 6 electrons, so we're down to 8 electrons left. All right, so where should we start with those? Fluorine, more electronegative, so it might as well get first dibs, right? How many electrons does fluorine still need? An additional 6. So now we're down to 2 electrons left. So where do they go? They've got to go to the nitrogen. So there's your full credit Lewis dot structure. So that's when I'm assigning points for this one. The Lewis dot structure is going to be 3 points, the electron geometry 1 point, the molecular geometry 1 point. So that's 3 out of your 5 points for this part. Gloria? The octet rule applies to everything in the second row and higher. You can go past the octet rule. Everything needs at least 8 electrons. But you can go past the octet rule if you're in the 3rd row or below. So I guess everything in the second row needs exactly 8 electrons to fill its valence. Hydrogen only needs 2 electrons to fill its valence because it's in the first row. So hydrogen and helium can't go past 2. Nothing in the second row can go past 8. And once you get to the third row and lower, you can go past 8, but you need at least 8 for it to be considered to have a full valence. All right, so there's 3 points out of our 5 for this question. How many electron groups are there around the nitrogen? 4, right? 3 bonds plus a lone pair that still takes up space. So what's the electron geometry? Tetrahedral. Right, because there's 4 things taking up space, so it's going to make that 3-dimensional shape that looks like a hydrogen going into the board, a hydrogen coming out of the board, a fluorine in the plane of the board, roughly 109 degrees from this lone pair, but I'm not going to get out a protractor, right? Just don't draw it as 90 degrees from the lone pair. So the way that I usually estimate it is most people can visualize what 120 degree looks like. Think about a peace symbol. That's basically a circle. It's a peace symbol, then you also have that. But if you can visualize what that angle looks like, that's about the angle we're looking for when we're drawing these. Yeah. You could. That if you're not confident in your ability to show it by drawing the right angle, you could write 109 degrees. And then there's no question. Yeah. No, good question. That was going to be my next point. It doesn't matter which of these goes in which place. Technically, every single one of these positions is adjacent to all 3 of the other positions. Right? So no matter where you draw the fluorine, it's next to 2 hydrogens and a lone pair. So I typically, if I have to draw a lone pair on a tetrahedral structure, I'll put the lone pair in the plane of the board because that's easier to show. But there's nothing wrong with doing that. It just looks a little funnier. Right? But because all of these are identical with respect to each other, and because this isn't OChem yet, we don't need to worry about chirality, which is when you have something where the mirror image is not the same molecule. In this case, you can put anything in any position because they're all adjacent to the others. If you want to think about what it would be like if the mirror image is not the same molecule, it's kind of like how your right hand is a mirror image of your left hand, but they're not the same. Right? They look the same, but you can't put your right hand into a left-handed glove. That's something we spend a lot of time with in OChem and in biochem especially. Turns out that matters a lot for medications. All right, so either drawing this or writing tetrahedral is acceptable here. For the molecular geometry, does anybody remember what the name is for this one? Trigonal pyramid. So you could write trigonal pyramid. Or you could draw basically everything in the same position from before without the lone pair. Right? Either of those is acceptable. So if you're looking at it from the amount of effort point of view, when it comes to studying, it's probably faster to learn how to draw them all than it is to memorize their names. In terms of on the test, if you're worried about time pressure on the test, it's a lot faster to be able to say tetrahedral than it is to draw it twice. So, but I'll leave that up to you. Part of this class is learning how to take a test, right? Specifically my kind of test, but in general, plan for what you're good at. Desiree? I always struggle with that one because I don't want you to take a scattershot approach. If it's one of these two, so I'm going to draw it one way and then I'm going to name it the other way. I don't want to incentivize that. So if it's written down, I do have to take it into account. So if you drew it properly but wrote trigonal planar, I am going to take points off for that. Probably like a quarter point. If you just wrote trigonal planar and you didn't draw it, that'd be a half point off. So you get still some amount of points off. Just because if you write it, I have to grade it. And if you write two things that are contradictory, something has to give, right? Ayla? So if we did that, like that, you mean? Now fluorine has 10 electrons. And fluorine is in the second row, right? So it can't go past the octet rule. Plus, actually, if you actually count out the formal charge, this has everything has a formal charge of 0, which is better. Even if we could do this, which we can't, that would give fluorine a formal charge of -1 and the nitrogen a +1, which isn't as good. Asen, and then I'll come back to you, DM.
So on the chart, the lone pairs are just for like visualizing, we don't actually draw them out.
I want you to draw them out on the electron geometry part and then not on the molecular geometry part. Because the electron geometry, you show everything that's taking up space. And then the molecular geometry says, well, but we can't see that lone pair. So basically, if you draw it right for the electron geometry, your molecular geometry, draw it the exact same way and just erase all the lone pairs. Okay? DM?
Which way would you prefer that we write it? Like how we had it there, or would you prefer that we write like the double bond?
Well, so you're not going to want a double bond in this case. So let's say it was bromine. Bromine is now in the third row or fourth row of the periodic table, so it can break the octet rule. If we drew that, remember that if we're not sure, if we have two options for our Lewis dot structure that both satisfy our first two criteria, remember our first criterion is the right number of electrons. Second criterion is everything has a full valence, right? The third one is all formal charges as close to 0 as possible. The closer you can get the formal charges to 0, the more stable it is. Yeah. Because if you draw it like this, that nitrogen's got a +1 formal charge and that bromine has a -1 formal charge, which isn't as stable as that. Because now nitrogen's got a 0 and the bromine's got a 0. So only take a lone pair to make a double bond if it's going to get your formal charges closer to 0, or if you need to fill a valence. Josh? Okay. Isabella? For this one, I don't think it matters. Or you mean like these names? No. Yeah. IF3. Yeah, that's a good one because that one does break the octet rule. And just because vocabulary trivia, I always found kind of interesting. Does anybody know what the singular form of criteria is? Criteria is inherently plural, right? It is criterion. Just like data is inherently plural, the singular of data is datum. If you want to be really pedantic and drive everybody nuts next time you get together, bring something like that up. Yeah. So it's words that came from Latin that ended in So I guess technically the plural of lithium would be lithia. Anyway, back to IF3. How many electrons do we have to work with? 7 and another 21, right? So 7 electrons from the iodine plus 3 fluorines, each of which also brings 7 electrons to the table. 28 electrons. Out of iodine or fluorine, what's going to go in the middle? Iodine. Start with our 3 bonds. That used 6. Now we're 22 electrons left. Each fluorine still needs another 6. So this is looking really familiar, right? It should feel the same for the most part. The trickiest part really is usually counting your electrons and figuring out what goes in the middle. All right, after that, it's the same thing every time. Every fluorine needs another 6, and there's 3 fluorines. So that's going to be 18 of our electrons that are left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So where do the last 4 electrons have to go? They've got to go on iodine. We already know that 1 pair going there makes a lot of sense, right? And now everything has a full valence, but we still have 2 electrons left. And our number 1 rule is we have to use the right number of electrons. So the other pair of electrons can't go to a fluorine. Why not? It's already got a full valence and it's in the second row, so it can't go past the octet rule. So with that in mind, this would make the most sense. And it should also make the most sense from a formal charge point of view. In this one, we don't really have any options. We have to put the electrons on the iodine, right? But if we look at the formal charge on each fluorine is 0. Formal charge on the iodine owns 4 electrons outright and then 6 in bonds, right? Which gives it a total of 7 electrons that it owns, which matches the periodic table. Right, so that gives the iodine a formal charge of 0. And all the fluorines have a formal charge of 0. All right, so there's the Lewis dot structure. Again, that's 3 out of the 5 points on this question. What's the electron geometry? We've got 5 things taking up space around the iodine, right? Which means it's trigonal bipyramidal is the name, or trigonal bipyramid, which is going to look like that. Another way of visualizing this is it's basically a trigonal planar shape where these are all 120 degrees from each other, with a fluorine sticking straight up from that plane and a fluorine sticking straight down from that plane. Right? So it's still that same flat trigonal shape, just with an additional one thing sticking up, one thing sticking down. Yeah.
Right, like it's not gonna be like a bunch of like forwards and backwards ones. What's the-
It will be one of the 5 that I've given you, which were linear, trigonal planar. Those ones are flat, right? So those ones are easy to draw on a piece of paper. Tetrahedral, trigonal bipyramid, and then if there's 6 electron groups, what do you get? It's octahedral, which looks a lot like this, except so you get something that's like a square planar with one thing going up and one thing going down. Right, but it's going to be one of those 5. Everything for this class is one of those 5 electron geometries.
Trigonal planar, tetrahedral,
In trigonal bipyramid, down goes between tetrahedral and octahedral. Yeah. You can just know the names or you can draw them. You decide what's easier for you. Right, so this would be this would be the electron geometry. I know I drew it underneath molecular geometry, but that's just because I drew everything too big over here. So this is the electron geometry. Or you could write trigonal bipyramid. What would the molecular geometry be? Once we have this drawn, the molecular geometry is actually pretty easy to draw. It might take more time, but all we have to do is draw everything the exact same way and then erase all the lone pairs. Not quite. It actually looks T-shaped. Yeah. So just because we can't see the electrons doesn't mean that they're not pushing everything else away. So everything will stay in the same position for the molecular geometry. We just can't see the electrons. Right, so it's the same basic shape. I'll draw it in a different color.
Starts on geometry column
On
it shows all the numbers in the line.
technically, yes. The way if I wouldn't say it's wrong, as long as you understand that if there's lone pairs, we can't actually see them, and that's why we have a different name for them. Right, so the showing the lone pairs isn't wrong for it's if you're only going to draw it, we're going to say that that's wrong for the test. Does that make sense? I see a hand over here. Yeah.
Geometry include electron geometry, or it's 2 separate.
The electron geometry defines the molecular geometry. Right, so they're always going to be tied together. Your molecular geometry is always going to be a subset of the electron geometry. Whatever your electron geometry is, dictates your molecular geometry. Yeah. For molecular geometry, yes. For molecular geometry on this test, I don't want to see the lone pairs unless you're going to give me the actual name. Right? But what we're doing for this class is we're saying, okay, draw the lone pairs in the electron geometry, and then when you can't see the lone pairs, that's your molecular geometry. These charts are trying to convey a lot of information, which is why they have them drawn with the lone pairs drawn and then with the name next to them. Unless you're gonna give me all of that information, though, I don't want to see the lone pairs on molecular geometry. Yeah. Nope, this is about as complicated as it'll get. Yeah, Maddie. Absolutely. Let me make sure that we're wrap this up first. Vinny?
So could you draw the electron geometry? And just draw the same thing without the left pairs from the left?
Yeah. All right, any other questions on geometries or Lewis dot structures before we move on? All right, I'm going to. I assume everybody probably has their practice test with them, but I don't. So let me pull it up on the screen so we're looking at the same thing. The question was for
Or the last one.
yeah. Grams per milliliter into pounds per gallon. So combined units. When we're going to convert combined units, there's two approaches. If you don't immediately. So usually one of the two approaches will make more sense to you. I don't care which way you do it, so do it whichever way makes sense, and I'll work through both ways right here. So one way to do this is to turn this conversion into two conversions. 13.89 grams per milliliter is really saying 13.89 grams is equal to 1 milliliter of that substance, right? So you can take 13.89 grams and convert it to pounds, and then take 1 milliliter and convert it to gallons. And you're going to get a number that's grams, or that you're going to get a number in pounds and a number in gallons, and then you just do the division with them. Right, so grams to pounds, that's a one-step conversion. That's actually not too bad, right? 13.89 grams for every 453.59 grams is 1 pound. So we'll get a number in pounds that'll be small. We want to go milliliters to gallons. 1 milliliter. 1,000 milliliters. Actually, there's a couple different directions you can go based on the conversion sheet that you have. The way that I would go that uses all exact conversions only requires that you have two numbers memorized, but again, you don't have to have these memorized. So you could take this either way. How would we normally go from milliliters to gallons? What's one approach? Milliliters to liters, to quarts, to gallons. That works. Or you can go milliliters to cubic centimeters, to cubic inches, to gallons. That involves doing a cubed conversion in there, so that one's a little bit trickier, but it will give you all exact numbers. Plus I have all these conversions memorized. I don't have all these conversions memorized. So my default would be to go to the bottom version, but as long as you round properly, it shouldn't change your final answer. Maybe be off by 1 decimal place, by 1 sig fig. So milliliters to liters, 1 milliliter. For every 1,000 milliliters, it's 1 liter. And it's what, 1 liter is 1.0567? Or do I have that backwards? 1 liter is 1.0567 quarts. And then 4 quarts is 1 gallon by definition. So how many sig figs do I get to keep here? What's our lowest number of sig figs on this bottom one? That's infinite number of sig figs because this is a conversion within the same system, right? So it's not about 4 quarts is a gallon, it's exactly 4 quarts is a gallon. This is a measured number because we're going imperial to metric. So that's 5 sig figs. This is exact because it's in the same system. Is this exact? This is a measured number. The 13.89 is considered a measured number. Usually what we do is we assume we have the same number of sig figs on the bottom with these combined units. You either assume that the bottom unit is exact and the top number is measured, or you could just treat it like it's the same number of sig figs. So we could treat it like it's 4 sig figs, just like the 13.89. I typically, just like with a percentage is measured, right? But the 100 part of a percent is exact. So I would usually consider this to be an exact number. But again, as long as you keep at least 4 sig figs when we do this, and we round to 4 sig figs at the end, it shouldn't affect your answer. And I won't mark that down. All right, so we'll get a number here. It'll be a really small number. This will also be a small number. What do we get for pounds? Give me one more sig fig.
0.
We have to go all the way out there because remember, this 0 doesn't count as a sig fig, right? It's tempting to say, oh, it's behind the decimal point, therefore it counts as a sig fig. It's a leading 0. It's anything to the left of the first non-zero number, not anything to the left of the decimal point. So this is 4 sig figs. And then what do we get down here for milliliters? 0.0001 over 4. So 0.00025-ish. 26264 and one more. So we just said that 1 milliliter is 2.641 times 10 to the minus 4 gallons. And then we know that 13.89 grams is this many pounds. If we want this number in pounds per gallon, once we have the number in pounds and the number in gallons, we just do that. We just do the division. This number divided by that number. So it could be a calculator error. I just went with the first number that was shouted. What's everybody else getting with other calculators? Does this look right or is this the wrong number? This will give us something a little bit under 100. So 0.03. So probably a calculator error. I don't remember where I got that first number, but this, if we're getting a bunch of people with different calculators all saying this number, go with that. And just as a note, when I'm grading these, most of the points is, did you show your work properly and have the right approach? And then actually plugging into the calculator, if there was a 10-point question, 9 of the points is setting it up properly. The 10th point is actually plugging it into your calculator, right? So it's not that big a deal to get a calculator error. If everything looks right, but you have the wrong answer on the test, I'll usually just write bad math or calculator error, something like that, and take off a point. DM? That'll be the next approach, is to do this all in one line. It's the same mathematically, so it shouldn't give you a different answer. But just to finalize this, 0.000261 gallons, 0.03062 divided by 0.0002641, and that looks about like 115. So what did you get, Liam?
15.
Let's do a reasonableness check. That's kind of a big number. What is it? Think about something that, like, think about a gallon jug of milk. How much does a gallon jug of milk weigh? Roughly. 5's not a bad estimate. I just always assume milk has the same density of water because it's pretty close, and water is about 8 pounds per gallon. So this is saying something. Now picture your gallon of milk, except it weighs 115 pounds. That's really heavy, right? Is it too heavy? This is pretty dense though. 13.89 grams per milliliter. That is about, well, water is about 1 gram per milliliter. So it's about 14 times more dense than water. 14 times 8, gonna give us something in the 100 region, right? So this is actually a reasonable answer. It just seems really heavy when you try to put it into everyday terms, because this is the density of mercury. Mercury, it turns out, is really, really dense. It feels really funny because it's liquid and it flows like water. But when you move it around, it is so dense. If you like swirl it around an Erlenmeyer flask, the conical flasks, if you have liquid mercury and you flow it around like that, it's really kind of disconcerting because it doesn't behave the way you're used to liquids behaving because it's so dense. Jason? It is. I don't know if that's what they use mercury for, but I do know that there's mercury in a lot of the tailings from gold mines. Modern gold mines that use erosion basically to mine for gold do produce a significant amount of mercury. I wonder if that's why. All right, so the other way to do this. It's not really any more work or less work, but it allows you to show it all in one line. Is basically to treat it like it is a combined unit, because it is a combined unit. So if we have 13.89 grams per 1 milliliter. We can cancel out milliliter by multiplying by 1, just like we do with all of our other conversions, right? It's just is going to look a little bit different because it's on the bottom of the fraction to start instead of the top of the fraction. So we can still say 1,000 milliliters is 1 liter, and that would give us grams per liter. Right? So we can still cancel out our units. We're just going from bottom to top instead of top to bottom. So, and it winds up being all the same steps. Because then we can say 1 liter is 1.0567 quarts. 4 quarts is 1 gallon. And that'll give you an answer in grams per gallon. Then if we want to cancel out grams, we can do the same thing we normally would do and say 453.59 grams is 1 pound. So milliliters cancels milliliters, liters cancels liters, quarts cancels quarts, grams cancels grams. And mathematically, it should give us the exact same answer. For some people, this way makes more sense, or if you're good at conversions and this way makes sense to you, this is probably a little bit faster. It'll save you 1 step on the calculator because you don't have to do that last division at the end, but should give you the exact same answer at the end. Destiny?
Is it wrong if you go for grams to pounds first and then to milliliters? Yeah,
All we're doing is multiplying, right? And multiplication has that, is that the commutative property that it doesn't matter which order it's in. So it doesn't matter if you convert grams to pounds first, or if you convert milliliters to gallons first, mathematically you should get the same answer. The way that my high school chemistry teacher taught me was to always do the bottom one first, just because otherwise you might forget it. If you do the top conversion first, you might forget to come back and do the bottom one. But you're less likely to do that if you do the bottom first. I don't know how true that is, but that's just what I was taught. Yeah. Oh, 3 on the conversions. So 2 liters to cubic feet. And again, if you had access to the internet or something, you could look up a conversion that's not going to be an exact conversion. You could look up a non-standard conversion. If you could probably just Google liters to cubic feet conversion. Thing is, I don't trust Google, and I really don't trust ChatGPT to be giving me the right numbers. So I always go back to the conversions that I know are true. And in this case, on the test, I'm limiting you to only the conversions that are on your conversion sheet. Even if you have some random conversion for liters to gallons memorized, I don't want to see that on the test. I want to see you use the ones that are on our conversion sheet. So in this case, we're trying to go from liters to cubic feet. We know we've got to do a conversion from metric to imperial somewhere in there. This is another one where there's a couple of approaches. You could go from liters to gallons, do liters to gallons, gallons to cubic inches to cubic feet. Or the way that I would usually go would be liters to cubic centimeters to cubic inches to cubic feet. Again, they should both give you very similar answers. This one was a little bit better because these are all exact conversions. We have an exact conversion to go from liters to cubic centimeters. And then we have an exact conversion to go cubic centimeters or centimeters to inches. And then we have an exact conversion inches to feet. So for sig, if you're paying attention to your sig figs and your uncertainty, the bottom one is a little bit better. But if we only care about 3 sig figs, our conversion to go from liters to quarts has 5 sig figs, and our starting answer is only 3. Our starting number is only 3. So for this problem, they should give you the same exact answer. But again, the tricky part with this one is remembering that when you're converting cubic centimeters to cubic inches, you've got to do it 3 times because you have centimeters to the 3rd power, or centimeters times centimeters times centimeters. So if you're going to convert centimeters times centimeters times centimeters into inches, you have to do it 3 times. You have to convert all 3 powers of centimeters to inches. So you could say, okay, 2.00 liters. 1 liter is 1,000 cubic centimeters. Then you can say 2.54 centimeters is 1 inch, but do it 3 times. So we're going to take 2,000 and we're going to divide by 2.54, divide by 2.54, divide by 2.54. And then we can go inches to feet, because everybody has that one memorized, right? But we've got to do it 3 times. When? You just need to remember, so when we do this, the cubed gets distributed to every part of this conversion factor, right? So 1 cubed, but that's just 1. Inches cubed is what we want. Centimeters cubed is what we're canceling out. 2.54 cubed. Just if you don't know where the cubed button is on your calculator, or you're not used to using the caret symbol, you can just type in over 2.54 over 2.54 over 2.54. Better option would be, you know, if I was typing this in to calculator, it'd be 2 times 1,000 over 2.54 caret 3 over 12 caret 3. We were first learning how to write essays, probably in like 5th grade or so. Did your teacher give you feedback using caret to say like insert a word here, like you forgot to write in? I always thought it was like a carrot, like the vegetable carrot. Turns out it's actually a totally different word. Like nobody ever said that. Like if I forgot to write, electron geometry, I could say, oh, don't forget to put electron geometry in this sentence up here. It's actually the same character. It's actually not spelled like the vegetable though.
Spelled like the carrot with a K.
It's not spelled like carrot with a K either. It's actually a 3rd version of carrot. C-A-R-E-T. And I have no idea where that term comes from, but it's not like jewelry carrot and it's not like a vegetable carrot. All right, we've got 15 minutes. Does anybody have more conversion questions? Or does anybody have anything else they want to go over that's on the practice test?
On page 4, when it's the electron configuration, your strontium is really not even page 4 or the conversion on the regular.
All right, so for electron configuration, if it doesn't say complete electron configuration, and it's more than 18 electrons, you can use the noble gas shorthand.
You won't be marked down for not using shorthand, right?
You won't be marked down for not using shorthand. So when in doubt, write it out the long way.
The strontium, since it says that it has this +2 charge, and that would make it have the same configuration as I guess krypton. Yeah, so would we have to write the shorthand with argon instead, because you can't write.
So for strontium, when it's neutral, it would be krypton plus, what is that, 5? 5s2. Yeah, that's the 5th row. Strontium 2 plus, I don't want to see just krypton. It's not technically wrong. You could say that your electron configuration is just this, but that defeats the purpose in this class of me testing you on can you write an electron configuration, right? So go back 1 row in this case. So go to argon. And then get 4s2, 3d10, 4p6. Right? Again, it's not technically wrong, it's just kind of a tautology. Well, 2 equals 2. It equals krypton. What is kryptons then? Right? So for this test, I want you to show me go back 1 row in a case like that. Keegan, and then Tanya. I would prefer the number 1, but it's okay for the questions on the stoichiometry on the reaction balancing.
Yeah.
If one of these is a 1, if we don't have the blanks written, normally we would just assume it's a 1 if nothing's written. So if you leave it blank, I'll assume you mean a 1, but I would prefer a 1 in this case since I explicitly left room. But I won't mark you down either way. Yeah, honey.
I was just wondering if you ever mentioned having a quiz this week,
Last weekend?
like for this weekend, is there?
There's not, because you're going into spring break and it just took midterm, so. So you won't have, after you take the midterm, you won't have anything to do over spring break until you come back. Unless you have outstanding assignments you haven't turned in which case spring break would be a really good time to get those turned in.
Wait,
know?
a lot of-
How specific do we have to describe them, how specific do we want them?
So the question's on the vocabulary page, on the front page, how specific do I want things? Show me you understand the concept. If you know it's a equation, like density is on the practice test, right? You can write D equals M over V. That's totally fine. That's an acceptable answer for that one. If you don't remember that, you can write something like the amount of mass per volume. But if there is a nice convenient equation and you know what all the variables are, you can just write it like that. Leonard, did you have a question? Yeah, so this class keeps, we do a rolling grade book. So you're still allowed to turn stuff in. That almost everybody's going to wind up with a higher midterm grade than they will at the end because I'm so behind on grading. So if you have outstanding assignments you haven't turned in from the first half of class, they don't say 0 on them yet, which is to your advantage for the most part if you have any missing assignments. I'm going to try to catch up on grading during spring break. But what that means is if for some reason your midterm grade is lower than your final grade in the class, talk to me or Tom's at the end of the class after finals or during finals week, and we will fill out the paperwork to go back and make your midterm grade the same as your final grade in this class. For pretty much everybody, it's going to go the other way. Almost everybody, you're going to have a higher grade at midterm than your final grade. But if you're one of those edge cases where it's not quite the same, then talk to us during finals week. Ayla? Yep. That's a really good point. So every one of these sections is worth 10 points. Obviously, some of these sections are a lot more work than others. So plan around that. Know where the easy, fast points are and make sure you get all the easy, fast points. And don't sink a ton of time into the easy, fast points when you know you're going to need them later on, right? So plan around how fast you can, like, everybody should be able to count protons, neutrons, and electrons and do an electron configuration pretty quickly, right? That's not gonna take a tenth of the time. But it's worth a tenth of points. So go fast where you can go fast and still get the answer right. Yes,
Is all of the tests gonna be on Thursday or is it gonna be like?
so we'll split it up. So problems 1 through 6 will be on Thursday. And Friday will be 7 through 10.
We could finish it before Friday. I mean, do it for that.
I would talk to Tom's. I'm not gonna be here either Thursday or Friday. If you need to take the whole test tomorrow, then maybe there a flex period tomorrow where they could do part of it.
Yeah, well, we could come talk to me and we could figure out, maybe start it early during third period. Running more.
The whole, you can finish the whole thing in one period, but you've got to be moving pretty quick. So you can do that. Just know that coming into it that you've got to, have a plan to get that done. Yeah. Nope. They're going to change, but it's going to be related terms and really big concepts. I'm not looking to trick you or find something you've never heard of. It will be words that you remember, even if you have trouble defining them. Okay.
So far, that's gonna be complicated.
It's all going to go into the same grade book. Does that make sense? Because we don't do midterm grades at the college, so I'm not used to that. That's not how the class is set up. All the grades go into the same grade book and you get one final grade. But here, because you need a midterm grade, we have to put something in. Does that make sense? Isabella? So I don't remember the exact percentages for this class, is like 20% tests in general.
Yeah, 10%.
So this midterm will be at 10% of your final grade in the class. And because it's a rolling grade book, that also means that if you do maybe less than what you want on the midterm, let's say you want to get a B, but you got a 70% on the midterm. That's okay, because all that means is that you have to do this, get a 70 or better on the final, and it's still going to bring your grade up. You can get a 75 on the final and still bring up your grade. As long as you do better on the final than you did on the midterm, because they go into the same category. Zach?
Yeah, like. What happened to this class?
We have to put in a midterm grade. So it'll just be whatever. I'm going to grade these as fast as I can over the weekend. And so and plug them in. So whatever your grade is, out of the first couple assignments and quizzes and the midterm, that's going to be what shows up as your midterm grade. But again, if your final grade in the class is higher than your midterm grade, talk to us during finals week and we can make sure that they match. We can bring up your midterm grade to match your final grade. Any other questions? We have 5 minutes. Any review questions? Maddie?
For tomorrow, like the midterm, we're doing like 6 pages tomorrow and then the stoic.
Right.
If you don't finish the 6 pages, are you just gonna be like, oh, you didn't finish like?
No, you still get to come in and do 7 through 10 on Friday. So I see what your question is. So no, you can't go back to problems 1 through 6 after tomorrow, because you could go look stuff up. It doesn't make, like, from a cheating point of view, that doesn't really make sense, right? I wish that wasn't the case. I wish we had a 2-hour time block, but we could just do the whole test at once. But we don't this week. Tasni?
But I was taught a whole another way, and I was just wondering for like maybe molecular geometry, if we would write this down too. Would that be part or do you need to-
So that's not really showing the shape of the molecule.
Okay.
That's a good way to start. But that's not gonna be, I don't want that as your answer.
Okay.
You can still write that. I'll know what you mean, but don't leave it there.
Okay.
Yeah.
So my question with the last page,
Mhm.
is it gonna be like similar to this where it's going to be convergent or end up being more of like?
So question about the wild card. Question number 10. It's gonna be a word problem of some sort. Probably mostly conversions, but as a word problem. There might be some really simple geometry involved, but nothing as complicated as the black hole problem. At most, something like the aluminum foil question. Zach?
So the last piece of slide, I made that paper, like, I think, a lot of it.
Yeah, not, both of those weren't supposed to be published. It was supposed to only be one assignment because there was a lot of duplicates in those two, so. If it's marked as late, it won't be marked as late. As long as it's turned in, before Friday, basically. Right, so don't worry about that. I know there's 2 nomenclature assignments. I didn't mean for that to be the case. That was an accident on my part. So just turn in the 14-page one. If you've to both assignments, and that you'll get full credit for both assignments. Right? Any other questions? All right. Then I'd say good luck, but you don't need good luck tomorrow because you put in the work and you're going to do awesome.
Extra tests.